Rightio, you see my purple texter? Don't be scared to shout out where it's gone. I love that purple texter. But anyway, I've got a replacement. Here we go. We're dealing with half equations today. And when we are going to assess you, I'm going to give you either a combustion reaction, a acid base, a double displacement, or a single displacement reaction. So, if we have a look at this, how was I so confident to be able to name those reactions as the way they were? Well, we go back to last video, we were pretty sure that any combustion, well, we're definitely sure that any combustion reaction requires a hydrocarbon and, of course, oxygen. You need oxygen to burn. And hopefully you remember that that would make CO2 and H2O. So I've managed to finish that half equation. I actually think these ones are quite easy to identify because you know that the products are always going to be the same. And of course, we would expect you to be able to balance this particular thing. So I'm going to put a 4 in here because I've got 4 carbons and 4 carbons. And then I'm going to put a 4 here because I've got 8 hydrogens over here, and 4 times 2 will give me 8. Now, if I was ever going to do this, I'd balance for my carbons, and then I'd balance for my hydrogens, and the last I would balance for my oxygens over here. So I would say, well, okay, so 4 times 2 is 8, and another 4 here is 12. So I'm going to need a 6 here for this oxygen. So let's just go back over that again. I've got 4 carbons, I've got 4 carbons, I've got 8 hydrogens, I've got 8 hydrogens. I've got 4 times 2, 8, plus another 4 is 12, and 6 times 2 gives me 12, so I would say that that is balanced. All right, so let's have a look at our next reaction. Now, this would, of course, require you to have identified this as being an acid and a base. Now, you notice in the last examples, I usually put the acid first, but it doesn't have to be that way. It can switch around. But we know that that acid and that base, of course, will form water on the other side. And once the acid and the base, well, what's left? Well, it's going to be potassium. And of course, it's going to be this sulfate. Now, the thing is, we need to combine this correctly. All right. Now, I know that potassium is a +1 ion, and I know that sulfate is a -2 ion. If you remember in class, we said that potassium had 1 electron to give away, and that the sulfate has 2 spaces. So one of those electrons will fill that space, and we will need to get another potassium. So I'll draw him up here. So another potassium for that electron to fill that space in its outer shell. So that means I will need 2 of these potassiums. Now, if we look at this, okay, everything's fine except the fact that it's not balanced. So I'm going to start off with my potassium. So I've got 2 potassiums here, so I'm going to need a 2 out the front here. And that is going to affect the amount of hydrogens I have. So I've got 2 hydrogens and another 2 hydrogens, which is 4 hydrogens. So I'm going to put a 2 here. And now, if we think about our oxygens, well, I've got 2 oxygens here and I've got 4, so I've got 6 oxygens in total. I've got 2 oxygens here plus another 4, I've got 6 in total, so I would say that that equation is balanced. So, double displacement, an acid base. Very similar to a double displacement, but as we can see, we had an acid and a base in this one. Now, I picked this one here because we've got a base, haven't we? But we don't have the acid. So in this case, we're not going to have an acid-base reaction. This is just going to be a simple and normal double displacement reaction. And that will mean, of course, that we will get potassium and hydroxide. So the metal from this one and the non-metal from this one. And then, of course, on the other side, we will get magnesium and we will get chlorine. Now, we have to be very careful here to make sure that we combine these correctly. So potassium is a +1 ion, so it's got 1 electron to give away. Hydroxide is a -1, so it has 1 space, and so they will fit together nicely. Excellent, we can leave that like it is. Magnesium is a +2 ion though, which means it has 2 electrons it wants to give away, and chlorine is a -1, so it has 1 space. Now, as we can see, there's too many electrons and not enough spaces, so I would grab another chlorine. And there we can see here that I have 2 chlorines, so I would need to put a 2 there. And that, of course, means that this is now not balanced. If I've got 2 chlorines over here, I'm going to have to put a big 2 over here to balance for 2 chlorines. But that means that I've now got 2 potassiums, so that's okay. Just put 2 here, and that means I've got 2 potassiums, but I've got 2 hydroxides, and that's fine because I have 2 hydroxides over here. So I would say this is balanced. So we pick this one as being a combustion reaction, we pick this one as being an acid-base reaction, and this one as being a double displacement reaction. So what's left? Well, this one, of course, which hopefully you've seen by now, is going to be a single displacement reaction. And what's going to happen is that this silver is going to come over here and it's going to replace the copper in the copper sulfate. So let's draw a line here. We're going to go, okay, Ag and SO4, and then we're going to have this copper by itself. And it was very close. I think we'll just scrub that out and we'll put it over here so people don't get confused. So we need to make sure we've got this correct. So silver is a +1, so it's got 1 electron to give away, but sulfate is a -2 and it has 2 spaces, so that's not going to work. We need another silver here. Of course, we need another silver, and so we're going to put a little 2 there. Now that of course means that it's not balanced, but that's pretty simple because we just need 2 silvers over this side, and all of a sudden the whole thing is balanced. So that's predicting chemical equations. Hope you enjoyed the video. This was a short one, which is good for my voice. Bye-bye.